That's it. You can start again. Sorry about that. Thank you.
Okay, no worries. So I've already introduced myself, but I'm Will Farley. I'm a solutions engineer at HashiCorp, and today I'm going to talk to you quite high level about HashiCorp Vault, which is one of our secrets management tools and one of our 6 flagship products. We're going to specifically dive into dynamic secrets as well, which is quite a cool feature of the open source version of Vault. But yeah, and if you have any questions or anything, then you can either feel free to butt in halfway through, but also I've got a bit of a time at the end for questions. So yeah, we'll just get straight into it. So a bit of like an overview of HashiCorp, really. I don't know if you've heard of us. You've probably never heard of HashiCorp, but you'll have heard of Terraform and Vault, for example. But as a company, we were founded in 2012. And today, I think we just crossed over 1,000 employees mark, and we've secured $349 million in crowdfunding as well. And we're growing fast as ever. Like in this space at the moment, obviously cloud, where it's most companies are realizing that this is the way that we should be going with things. So yeah, we're growing super quickly. This growth translates to like 700 enterprise customers, or more than 700 enterprise customers. And of the Fortune 10, we have 7 of the 10 7 of the top 10 Fortune companies, and also 8 of the top global financial companies as well. Some of the logos in the background, I won't go into any more details just in case I say something that I probably shouldn't. So what is like HashiCorp's vision really? So like first we start with a lot of companies we see with like, they're in traditional data centers, and they're now being born into like a cloud native sort of way of working. But like, say if you're here today from a company with like I don't know, with OpenStack and like some VMware in your like data center, but it has like static attributes that you are now like recognizing and need to improve, whilst taking still advantage. You want to take advantage of the public cloud in some sort of way. So you kind of have like this bricks and mortar data center, really, like a fleet of servers, a bunch of storage, and like a network. And you've gone through this like virtualization journey, and you've realized that you actually want to be multi-cloud. You want to use Kubernetes. You want to use Nomad. You want to sort of bring your infrastructure up to date and modern. So yeah, you want to move into this sort of multi-data center sort of way of leveraging basically like cloud compute and elastic resources. So you're now potentially going into AWS, GCP, like Azure, Ali Cloud, because this is like the modern dynamic way. But this in itself brings its own challenges. It's never an easy journey, as a lot of you may have gone through this. I've worked for companies before in the past where we are migrating from this dedicated infrastructure to this like multi-cloud, or even just into one cloud. And it's never an easy journey. I don't know if anyone else has any sort of stories of that, but yeah. So HashiCorp as a company at present have 6 main products. 4 of them here: Nomad, Consul, Vault, and Terraform. These are the ones that we sell to companies, but also you will have probably heard of Packer, but also Vagrant, which is the first product that we released and by far our most widely used. The HashiCorp platform at each level sort of creates a centralized control plane and like a common operating layer across each level of like delivery. So for example, at the run level, you might want to run some sort of like on-prem Kubernetes or something like that on your private cloud, or just run physical servers. And then in AWS, you might want to use ECS, for example, like the AWS's container service. Same in Azure and GCP, you might have different sort of methods for each one of these. Another great example is Terraform. For your private clouds, you might have wrote a bunch of scripts or just configured things manually. AWS, you might want to use CloudFormation, but then you're sort of facing an issue of where you're wasting time, and it's quite complex now that you have a different technology per segment, basically. Whereas HashiCorp sort of tries to condense all that, where you're writing one piece of infrastructure for the whole of your actual estate. For example, Terraform, you can write Terraform for most of the big, well, all of the big cloud providers, plus other things such as like Auth0, for example. We have Terraform providers for that. It's just one language fits all. Same with Vault, Consul, and Nomad too. And we're going to touch mainly into Vault in a second as well. So what is Vault basically, and why did we even create it as a product? So as I've said, the traditional data center had like 4 walls basically and a pipe going in. So that's like kind of a weird way of saying it. But beforehand, there was literally one pipe in, and once you're in the network, then you know you're in the network. But now you're moving towards more dynamic infrastructure with like a service-based identity. So what does that mean? So you're moving from a high to a low trust network in public clouds. So in public clouds, like there's a lot of unknown network parameters, and also it's split across multiple clouds. So you don't just have one pipe in anymore. And also you're moving from more of like an IP based enforced security, where you have physical like firewalls on the instances and things, to a bit more of like maybe auto scaling groups and things, maybe with load balancers in front and stuff, with just the security groups all over the place. So you kind of have less consistency now in the way that you're dealing with security. So you now need to have like application identities instead to deal with that. So like I previously said, the traditional data center, it was like quite easy to define network parameters. Like anyone inside the network is assumed to be authorized. But not only that, like the operator error can easily create like vulnerabilities, because the network topology is like software defined, and any server can become like internet facing without replugging a single cable, for example. This lack of control makes it hard to enforce traffic through for like security and compliance. So that's why we've created Vault, which is going to sit underneath all of your infrastructure, that service every single one of these components, and basically completely reduce the need for any complex networking and firewall and things like that. Well, the sort of the risk for having complex networking now has been dramatically reduced. So like all HashiCorp products, Vault is it's a single binary. So whether you're running it as a client or if you're actually running a Vault server, it will be the same binary. So Vault is a tool for like securely accessing secrets mainly, and a secret being anything that you want to tightly control access to, such as API keys, passwords, or certificates. Vault provides a unified interface to any secret, while providing tight access controls and recording like detailed audit logs and things. A modern system requires access to like a number of secrets. So for example, an application might need database credentials, it might need API keys for like external services, or credentials for like a service-orientated architecture of like for communications and stuff. Understanding who is accessing what secret is already very difficult and platform specific, but adding on key rolling, secure storage, and detailed audit logging is like almost an impossible solution to create. I've worked in companies before in the past that have tried to do like fudge things like this themselves using a bunch of products that are out there, and we just never get it right. For one reason, we might, there's little to no logging potentially, or we might struggle with key rolling, so we just don't roll the keys. So this is where Vault now steps in. Vault integrates as well with the majority of the authentication providers, such as like AWS IAM, Okta, Azure AD, etc. So there's like a single place for companies to add and remove users, and when it comes to like managing secrets, so you don't have somebody left in on an instance that, for example, has left the company because you've already removed them from their AD, from Azure, from your AD or your LDAP or whatever. The other side of that is that Vault integrates with the majority of like databases for actually managing secrets, and most other secrets backends as well. So for example, we're going to talk today about databases. That's why I keep talking about it, but we can also integrate with AWS IAM, SSH engines, etc., etc. So dynamic secrets. So what is this actually trying to solve in a sense? So within Vault, there is a key value store. So you can store passwords or just generic data yourself in this key value store. However, this itself like brings a lot of problems. So secret sprawl, in a sense, it exists still because even though you've got these like potential usernames and passwords have now been checked into Vault, which is secure, there is still a chance that that data has previously been checked into source code or like hard coded into application config files, or someone who you just sacked from your company has wrote a list of all your passwords down and left, basically. There's still kind of a risk of that. So yeah, if someone leaves the company who's previously had access to Vault, they could have all your secrets still. Therefore, Vault has this idea of having a dynamic secret. So unlike the KV secrets, so like the key value secrets, where you put this data in the store yourself, dynamic secrets are generated when they are accessed. So they don't exist basically until they are read. So a secret does not even remotely exist. The username and password for a database just doesn't exist until they are physically read. So there is no risk of someone stealing them or like another client using the same secret or whatever. Vault has a built-in revocation mechanism. So each role can be associated with a lease. A lease being the amount of time the credential can be used until it's immediately revoked. So this minimizes the time that even the secret even exists. So I can put an hour's lease on it and I can only use it for an hour, for example, if that makes sense. So take this diagram, for example. I found this on the internet and I thought it's brilliant because this is exactly what I'm going to demo. So so a user has authenticated to Vault with a valid auth method. So for example, LDAP. So this person then requests a DB credential. Vault will then check to see what roles this user has access to. And if it passes these policy checks, Vault will then create a username and password on the database. It will then return this credential to the user for a certain amount of time that is specified in the role. So for example here, if it's 7 days, it will return the credentials for 7 days, and then Vault will go on and delete them 7 days later. Or this can be forced manually as well. So I'll actually go into the demo now where I'm going to show that. I'm using a few different tools. So I'm actually using AWS RDS, but also Terraform and Vault. So I'll quickly touch on Terraform. I'll show you my Terraform setup quickly. So I'm using one of our products called Terraform Cloud. So it's basically Terraform Enterprise, but the SaaS offering. So it's free to use as well. But not all the features are free, but I mean, it's worth probably logging in, creating an account, having a little play around, because to be honest with you, it's quite cool. As a DevOps engineer, I've had multiple times of needing to create like Jenkins pipelines for Terraform jobs, or having to store secrets in like a secure fashion. But basically I created my AWS network with Terraform Cloud. It's basically a runner for my jobs. So you can see the output from my jobs, a plan here, cost estimation. So what it actually costs me. I'll run some policies, but that's a paid for feature, so I won't talk about it. But, and then it will do an actually apply for me as well. It will encrypt my state and store my state for me as well remotely. And also I can put variables here if I want to, and which I can create them sensitive just with the click of a button by just editing and clicking sensitive there. And I can also, what's really good about this, it connects to my VCS. So I've pushed all this code to GitHub, but it will manually trigger runs and stuff every time I push. And it will also queue runs as well if 2 people push at the same time and stuff. So it's quite neat. And also I can change the version of Terraform so I can roll it up. But basically what you've got to take from this is I deployed my infrastructure with Terraform using Terraform Cloud. And if you haven't used it already, I would definitely recommend you check it out. So into the demo then. So I'm going to create a Vault server just running locally. So the great thing about Vault is, like I said earlier, it's a single binary. So I can run a dev server. So here I'm specifying dev, which basically is a pre-configured sort of locally runnable server where I can just quickly, you'll see how fast it is, but where I can quickly just configure a server, get it up there. So I want you to think of this as a user case of, I'm a developer. I am developing some software at the moment, an application which needs to talk to RDS for whatever reason. And I need to basically test my integration with Vault, i.e. getting dynamic secrets. So I think that's it sets a bit of a scene. I'm specifying my root token here just because if I don't specify it, it will give me a random string that I'll have to keep on copying and pasting when I log in, but I'll hit that. So as quick as that, I've already got a Vault server up and running. It was literally less than a second, half a second, even less. Worth noting that it's automatically unsealed as well. This wouldn't be the case in production, but just for this demo, I've just used this dev mode. Okay, cool. So we can actually go and look at the UI as well. So one good thing about Vault is it comes with a UI, which, here we go. So I can log in with the root credential that I've just typed in, which is root, and sign in. So this is Vault. Everything that you see here, you can do in the command line or use like API calls and stuff. But yeah, so basically we want to add a new secrets engine. So the idea of a secrets engine is what I talked about earlier, is we can connect to any database, we can connect to, I don't know, SSH engines, we can use it to manage certificates. So that's sort of the idea of a secrets engine. To create the new secrets engine, I'm literally going to type in this one. I'll shut this. Is that big enough, by the way, for everybody? Can they see my command prompt here? Is that big enough? I might make it a bit bigger, maybe. Is that okay?
Yeah, it really depends on the screen. Probably you can make it a little more bigger.
Make it a bit bigger then, yeah. We don't need to look at this one on the left anymore, so I'll completely close that down as well, make it super big. Right. So if we do a Vault Secrets enabled database, this will now enable the database secrets engine for me. So we go back to Vault, refresh it and log in again, and we'll see the database secrets engine. With this now, we need to configure it. So I can, you basically, I've not logged into AWS, but you can just say I do have a database running in AWS here. So yeah, so I mean, I'm going to configure that secrets engine now to point at this database. So if I go back to my command line, and I'll quickly show you this. I've got some clear text username and passwords here, but this database is only available for my IP address anyway. But so I can write. So I'm going to be writing a new database called my PostgreSQL database using the database plugin. I'm allowing all roles basically. So every single time I create a role, I could specify it here just as an added layer of security. But for this demo, I'm just going to say blanket wildcard. I'll accept any roles. Put in my host name and username and password and hit enter. And when Vault returns nothing, that usually means good. So now, so the next step, if we think back to that, if we think back to the diagram of the user requesting a password from Vault, now you need to start writing roles. So for this, I'm going to create two roles. I'm going to create a DB write role, so which has access to write on a certain database. And then I'm going to create a read role as well. So I'll create the write role first and try and log in because I'm going to play with TTLs as well, so leases. So here is the first one. So here you can see we're creating a new role called DB write on the my PostgreSQL database, which we configured up here. And the creation statements are just going to include some SQL, which I'm no expert in myself, but so I'm going to grant select, insert, update, and delete on schemas, basically on all the schema, on all tables in schema public. on this database here. So you see I've got a default TTL here of 3 minutes and a max TTL of 1 hour. So the 3 minutes means when I request this credential, I will have 3 minutes to use it basically, otherwise it will expire. So from the second I read the credential, it will expire 3 minutes later. The reason why we have a max TTL is because we can actually renew these credentials if needed. So if I get to 3 minutes, or if I get 2 minutes in and I think, oh, I probably need to renew this, then the max time that I can renew that secret for until I have to request another is for an hour. So it's just a good thing because we can revoke them, but we can also renew them manually as well. So I'll click enter. Sweet, we've now got a role called DB write. So I'm going to have to be quick now when I read this role, because I've always to give myself 3 minutes, but I think it's loads of time. But if I read this role now and I'll log into the database basically using this this Postgres client, and then we'll see, we should, because we gave ourselves grant, select, insert, update, we should be able to actually add data into a table. So let's try. So I've given myself now 3 minutes. So if I go over here, create a new server, server name, DB write, the connection, what's this? My password is here. My username being that one. So now if I go into here, we'll go into demo A table and we'll go to this demo A table and we'll have a look first at the roles that are currently there. We currently have four entries, one of them being true. So now let's try and add one quickly while we can. Query tool. So if we try and add one, so we'll try and insert into this table here a value. We'll try and add a value for false. I just created this as a Boolean, so it's one or the other basically, and click run. We got a successful, so let's now see if that actually worked. And we have another now value of false. So before I start this demo, these credentials didn't even exist. And then literally within 5 commands, I've managed to set up a dynamic secret basically for this. So we'd expect to see in 3 minutes time that we'll try and log into this again, or we'll try and do something on this DB write server and let's see if it works. But whilst we're waiting for that, let's create another one. So the next one we're going to create is a DB read. So this has just literally has grant select on the tables and the schema. So it's exactly the same as the other one, apart from we're not having insert, update, or delete as a role. So, and also we've increased the TTL to 15 minutes as well, just to give myself a tiny bit more time with this one. So if I've wrote that, and now I've wrote that role now, and I will now I will try and read this role. And sweet, so we now have similar sort of block from beforehand. If I just grab this again, so I'll need it. And I create a new server. Read. My username. And password. Save. Right, so we're now logged into this database. It's the same database. But let's see first off if we can see the roles. Brilliant, we can. So now let's try and add some data into this database. Query tool. Like I say, I'm absolutely no database expert, that's for sure, but I know enough just to get by for demos and things. So we'll try and add a value of true. It's exactly the same as what we did beforehand, but we should get permission denied, in which we did. So that just shows now we have two roles. So we have one person is a developer, for example, who needs to add stuff, data into these databases. So they have permission to do that. And then we have another role for if we have a contractor, for example, working who we don't actually want to be able to modify data, but they are allowed to see it, then we give them that role instead, because now they can't do that. So it's probably been about 3 minutes, I think, since, maybe a bit longer, which is good, since we created our DB write role. So we need to remember that we had a 3-minute lease on this. So if I do anything now within this database, we should hope, if it has been 3 minutes, that it will not work. So let's try. So if we try and view all the roles, we get an authentication failed down here, which is brilliant, which means the lease on this credential has expired and we can no longer use it. If we wanted to reuse it, we just renew it. If we ever get into a situation where we know someone's doing something malicious or something like that, then we can actually revoke these secrets as well. And it's worth showing here that it does actually say when the leases are revoked. It logs quite well. So you'll see that the MyDB write has revoked, but we set 15 minutes on the other one. So let's try and delete that. So if we do a vault lease revoke, and then we need to put the lease ID in. And we'll see it has logged already. It said it had queued and it has successfully revoked that. But let's just quickly check. Oops. And again, authentication failed. So we've very quickly there created some dynamic secrets basically for that database, allowing that now if somebody leaves the company at the end of the day, we have got 100% confidence that they cannot log into any of our databases or anything like that. So let me go back over here. So that's just a quick, in a nutshell, the dynamic secrets engine. But what other user cases are there for this? So it's like worth bearing in mind that these dynamic secrets aren't just to be accessed aren't just to be used for accessing databases. So, but what else can we use them for? So we can actually hook this up with AWS IAM. The reason why I keep going on about AWS is when I was a DevOps engineer, my 100% main focus was AWS, so that's what I'm most confident in. But you can hook it up to all the other ones as well, so like the GCP user managements and things like that, and Azure as well. But you can for this example, you can hook it up to AWS IAM and create dynamic credentials to access AWS. So for all different amounts of times. So therefore, like the risk of not deleting a user from an AWS account when they left the company is completely gone. As long as Vault is hooked up to your like central user management system like AD or something, and they get removed from AD, then they will no longer have access. The roles can be like altered as well on Vault to allow some people to have more access than others. So just as we've showed there, but sort of relay it to someone can only have access to RDS if they're a DBA, and then you might want your security team only having access to your network, or your network team only having access to networks and things like that. So that's so you can dynamically create AWS credentials, but also finally, you can dynamically create SSH keys. So if you wanted to log in to a box, but you don't want to have this, what I've seen before is you have this like central PEM file that gets passed around the whole company basically, and you use that to log into EC2 instances, and as such, that's super insecure unless you rolled it basically every single day. Because if somebody left the company and took it with them, they can still log into all your boxes and things. And also the manual task of having to roll these keys is a pain. So Vault can control access to instances as well via SSH. So that in a nutshell is Vault, quite a high level, and also dynamic secrets specifically with a quick demo. So I know I've filled half an hour there, but has anybody got any questions while we're here? I'd happy to take them.
So we were actually playing a game. In the background, we were trying to pose the best 3 questions.
All
It
right,
looks
nice.
like we have a couple of questions in the chat.
Right.
From Roman and a question from Shankar, and I leave the floor open for anyone else also to generally ask any questions related to Vault. Will.
Cool. Yeah, so I'll just have a quick read of these questions quickly. So what is responsible for dynamic credentials expiring? So what is responsible as in what? So I mean the Vault itself or underlying secrets engine? Vault itself, yeah. So Vault itself will, when you read the credential, Vault itself then kicks off as it basically gives you the time, 15-minute leash duration, and then Vault itself then will go and delete that username and password or that credential from the DB.